Good. All right, welcome back, everybody. How y'all doing? Had a good couple of snow days, I hope. Do you go to school here in, I forget where you are. Are you in Portsmouth? Newmarket. Okay, so yeah, you definitely got snow in Newmarket. Cool. So let's see, we had a week off, right? So we didn't meet last week, so it's been 2 weeks. I'm just trying to get reoriented here. So I think one of the last things we talked about at the end of last class was, so we did 3 sessions. And although we didn't stay totally true to sort of the topics that I laid out, we've basically talked a bit about mechanics or modeling, electronics a little bit, code a little bit. Those are sort of like how I orient people in the field of robotics. So we're kind of in the second half now, right? We're in class 4 out of 6-ish. So for the second half, things are going to be a little bit more self-directed, a little bit more self-paced. I'm still planning on talking a little bit at the beginning of each class and either introducing a new idea or going over a design idea or something like that. But there's going to be plenty of time in each of the classes for you guys to work on building out your own designs. But sort of as we go back around the merry-go-round a second time, talking about building the physical robot itself, working on electronics and working on code, I would like you guys to think about how you're making this design your own, whether it's modification of the existing robot or whether it's discarding that entirely and starting from scratch. Whatever you guys feel comfortable with, I'm totally happy with and happy to encourage you guys. But I do want you guys to kind of challenge yourselves a little bit. So pushing yourself outside the comfort zone. The other thing that I've mentioned this before, I want to reiterate, is so there's kind of 6 classes that are scheduled here, right? But when we get done with that 6th class, we don't all just fall off a cliff, or you put your robots away and never think about them again, hopefully, right? My hope is that you guys are interested in this enough that you're going to keep working on it independently. And whether that's on your own or whether you want to come back here and continue to work, both of those are options for you. This place is available. We're here basically every day until about 5. Anytime you want to stop by and work after school, it's best to ping us on Discord, but the place is here for you guys to work. And then if you guys need other time to work or something like that, we can try to work with you and figure that out. Obviously, we sometimes have other things to be doing, like on weekends, for example. But my hope is that when we finish with that 6th class, you'll take the opportunity to keep working on this stuff in whatever way kind of works for you guys. All right. So has anybody thought at all about their designs over the last 2 weeks since the last time we met? Yeah, I'm seeing some nodding heads. A little bit. That's all right. You're not getting graded. There's not really homework. So if some of you guys have some thoughts or ideas that you want to share, I'd like to talk about them. I also have been working on my own robot, and I want to kind of talk about that a little bit and how it relates back to sort of our second iteration through the topics here. Does anybody have some thoughts that they want to share? Like, what have you guys been thinking about in the last couple of weeks? Any of you guys have some thoughts about kind of what direction you're going? You were working on your design up here. Do you maybe want to share a couple thoughts about where you're going with the propulsion? That was not to put you on the spot. It's just we're just talking here, right?
So because servos.
Oh, hey, look.
Yeah.
I didn't. Okay.
Because servos have a minimum low rotational speed and a minimum amount of times they can rotate.
Yeah.
I decided to use DC motors, and these ones, the ones that are available here.
Yep.
And they're 2 watt. The robot would be really large if I put them in horizontally, so I decided to put them vertically, and then use a pole or a peg to rotate a belt 90 degrees, so that the drive can be perpendicular to the motor. So.
You know what I love about this? I mean, there's actually several things I like about this. First of all, it just looks really cool, but that's not the thing I love most about this. The thing I love most about this is at this point in time, you don't know if this is going to work or not.
I have no idea.
Right. That is the best thing ever. And that's actually a topic that I wanted to talk about today anyway. Yeah, the theory is fine, right? But here's the thing. When you guys are learning about building robots, right, there's a lot of stuff you don't know yet. and this is definitely true about my design that I'm going to talk about. I'm making some guesses, right? But if all I did was stay inside my head and be like, how do I design the perfect robot to do the thing that I'm trying to do? I'd never actually get anywhere with it. At some point, you just sort of have to like step off the cliff and try something. And when it doesn't work, just understand that you're going to make something different. You're going to revise it. You're going to try something else. Maybe you're going to throw it away and start again. It doesn't matter. That shouldn't keep you from trying to do the thing, right? It should just be the first step in the process. I think you can make this work. I think it's a great concept. But
I started here because this kind of like defines the size and dimensions of the rest of stuff. So if this doesn't work, it doesn't make sense to model the rest.
sure, yeah. So getting it to a point where you can try something and then see if it's going to work or not, that's a great first step. You know, rather than spending 4 weeks modeling the thing and then find out the premise that you started with, you know, was going to be problematic. Cool. All right. Anybody else have any ideas or thoughts that they want to share? No? No? Okay. Well, I don't want to put anybody on the spot. So let me talk for a couple of minutes about what I've been working on. So this is going to be a self-balancing robot, I hope. I've never built a self-balancing robot before. So, you know, like, I'm going to give it a try. So I modeled this over the break. It's over here. It might be a little hard to see for some of you guys. But so I just went into Fusion and I started modeling something that made sense based on either what I had seen before, right? Because there's a lot of self-balancing robots out there on the internet. Usually people build them with Arduino for some reason rather than Raspberry Pi, but I don't think it matters too much. And the only sort of like design criteria for this for me was to make it fit the components that I knew I was going to use. So I'm going to reuse the Raspberry Pi Zero that we've all been using. That made sense. I made room for, do you guys remember me talking about an H-bridge back when we were talking about switching? So an H-bridge basically lets you control DC motors and switch direction. So I have some H-bridge chips. See this little thing? It's kind of buried in here in the middle of the wires. So that's an H-bridge, just a little 16-pin integrated circuit. And I put it on a little breadboard with pins along both sides so that I could just plug the pin wires in like you do on the Raspberry Pi. It just makes it really easy to hook it up. So I just soldered up the chip onto the board with pins. And in the model, I gave myself a mounting hole. It's maybe a little hard to see from here, but the one that's below the Raspberry Pi holes down in the middle is to mount the H-bridge. And then I left enough room at the bottom for the battery to sit. So, I mean, this is super simple, right? It's a flat piece, another flat piece is the body. There's a flat plate on the bottom, and I use bolts to sandwich the motors in between, right? I didn't spend a lot of time designing fancy motor mounts. I just crammed them in there and squeezed two pieces of plastic together to hold them in place. And so this whole thing probably took me, I don't know, less than an hour. Like, I just threw it together. It was like, you know, once you're comfortable in Fusion, this kind of design is pretty straightforward. And then, so a bunch of you guys were in the intro class. You weren't. One of the things that we talked about later on in the class in modeling was some advanced ideas like creating a model that doesn't require support material to print. Right? Yeah. So, so the stuff that Jaden's been doing lately has required a lot of support material, and you spent some time pulling the support material off the model when you're done, right? It's a little finicky. Yeah. So this design here, because the flat plate on the bottom and the vertical piece don't have any unsupported overhangs, and this arch is the kind of shape that you can just barely get away with in a 3D printer where it prints up the sides and then the arch kind of comes in and meets in the middle. The wheels I can lay down flat, so there's no overhangs, and the bottom plate is just a flat plate with holes through it. So this whole thing can print without support material. So that's not a requirement. That's not something you have to do, but when you do, when you think about those things when you're doing the design, what that allows you to do is put all the pieces on a plate, hit print, go away, come back the next morning and your parts are done and there's no support material. It all pops off and snaps together. It's like super easy. So just sort of, you know, having those as considerations when you're doing your model makes your job easier a little bit down the line. So I'm not the best coder. I can sort of hack my way through Python a little bit. But I was chatting with Michael earlier today, and he's like, "Hey, do you want to try to get that thing working?" And we haven't gotten it working yet. That's the spoiler, I guess. Um, but we started to, and so all I did to get the code to work, and I'm going to be working on this over the next couple of classes with you guys. Like, so I'm going to work on this one while you guys are working on your designs. And let's see, is that, yeah, cool. So, like I said before, this isn't a slam dunk. I've never built these before. I don't know exactly how this is going to go, but just to sort of get the ball rolling, I've got an accelerometer. It's actually a accelerometer and gyro combination, right? So you can use both. And so it gives me readings when the thing rotates out of its balanced position, right? So I just threw together some code. It doesn't totally work yet, but I borrowed code to control the motors from the mini bots, because those use the same motors in the same H bridge. And I just wrote some a really short bit of code that takes a reading from the accelerometer and gives a greater value when this thing is rotating quickly off axis, and a very small value if it's moving slowly off axis. And so my hope is eventually I'm going to get this working fast enough that it's going to be able to balance itself. Now, there's some things I don't know yet, which is kind of the point of all of this. I don't know if these motors are going to move fast enough. I don't know if Python code running on top of a Linux operating system on a tiny $5 Raspberry Pi is going to be fast enough. Might have to make the wheels bigger so that they effectively move more quickly. Or I might have to up the voltage to the motors. I might have to change all kinds of things in order to get this to be responsive enough to balance. I don't know yet. But I'm not worried about that stuff yet. I'm building the mechanics first, then I'll worry about the electronics, and then I'll worry about the code, and then I'll find out all the things that don't work, and I'll have to go back and change a bunch of stuff. And that's just part of it, right? So anyway, so with the code that I threw together earlier today, you can see it's starting to work, right? When it tilts, it moves the motors a little bit. It's not fast enough. No worky, right? But it's at least showing signs of life, right? Maybe we'll get there, right? So anyway, so I'm going to be working on this over the next few classes as you guys are working on your stuff. And we'll see where this turns up in the end, right? So that's kind of where that's at. Anybody have any questions on that? No? Okay. The other thing that I mentioned is that we didn't spend quite as much time talking about the example code that's on the robots last class as I wanted to. So I want to get you guys working on your stuff, get rolling with that. Depending on how long, or depending on where we get to, and if we get to a good pausing point, I might kind of roll back and talk about some of that. But for now, why don't you guys get your stuff out, continue with your designs. And the thing I want you to remember today as you're getting back into it, if you guys aren't sure where you're going, if you're stuck on where you want to start with an idea, what your next step is, or anything like that, don't feel like you're in a jam, okay? Talk to me, we'll kick around some ideas, or talk to some of the other folks in your class, and let's just figure out how to get you unstuck. Come up with an idea, start rolling. If you're stuck in Fusion, if you're not sure where to look for what electronic parts you want to use or whatever, those are all problems we can solve. All right? Cool. All right, get rolling. So one thing I want to ask you is when you first started, you hadn't done modeling stuff before.
No. Well, okay. I haven't done in Fusion.
Okay.
I've worked in like Blender, and I have done some.
Yeah.
modeling.
That's cool.
So,
That's good because like that opinion about 3D modeling is that skills you learn in one program transfer over. Maybe not always directly or whatever.
Yeah.
So I think some videos I had put together as part of the.
videos.
I don't know if you've had a chance to look at those.
I did watch those.
Okay.
I did do some modeling.
That's cool. Are you comfortable playing around inside Fusion at this point, or can I help you to kind of take that in a direction? Okay.
But I'm pretty good, yeah.
Okay, cool. So that computer over there is running the stream, but we can fire up Fusion on that computer if you need one to work on. But that, of course, depends on kind of where you're at and where you want to
Yeah.
go.
So yeah, the robot's done.
Okay,
It's all wired up.
great. Have you tried it out? Like, have you fired it up?
I've turned it on.
Okay,
Never connected to it.
okay. So that'd be a great place for you to start.
Yeah.
Because if you get connected, you can download the example code and fire that up. And depending on how the robot behaves, that'll tell you if you have wiring problems that you need to troubleshoot or whatever. So I'd start there. Cool. All right.
So should I do that?
Yeah. So the stream is running, and so we can just kind of minimize this, and then you can fire up Fusion, or if you want to. You can fire up Discord through a web browser if you want to hop on, because there are there was like the getting connected document is linked in the Discord or whatever. Yeah, we have some in the drawer over here. What's that? Getting connected. There you
All right.
go. I think I have one of the motors in my bag.
So I have both of them right there.
Oh, you do? Oh, great. Okay.
I was just looking for something like rubbery and round in the circular.
Very Zoidberg.
Torus-like pattern.
So rubber? You mean to use for like a tread, or like for the transmission of?
Transmission.
I have some rubber bands.
That might work. Yeah.
You could also
Print some.
Yeah. Let me see what I have.
Just has more. I don't know how stretchy. I feel like having something elastic
Yeah.
to make
There's also some random binder clips in there, which are probably not helpful to you in this particular situation, but you are welcome to use them. So what are you thinking about, Gordon?
I can't connect.
Okay.
I connected fine at home,
Okay.
but then of course it wouldn't connect to the internet, so
Sure.
I couldn't get any code.
All right.
And it's just LoisLab, right?
For what, the wireless access point, or for the, yes, LoisLab, all
And I get
crammed
an
together.
error here when I do it.
Okay. Let me
Problem is,
I'm
of
sure
course,
we can figure it out.
It connected right up. I was like, oh, awesome. Now I'm going to download the code. And then it was like, oh, you can't connect the internet. And then I'm like, realized I probably would need to disconnect the thing and log into it as a computer and get in the operating system. I did play around and look at, gee, there's this, and I can't think of the file, but there was a file I could look at where you could see where it's set.
Yeah.
And that wasn't where it was supposed to be. So that's when I said, okay,
Gotcha.
I've hit my limit.
And then, okay, I see your wireless access points. Let me try to connect to that.
Now, and of course, once I connect it, it will disconnect me from your Wi-Fi, and I'll be connected to that.
Yes.
Which it is then connected to the Wi-Fi.
What's the IP?
Of what?
1.192.168.
Are you? It depends on how you're trying to connect. So, are you? The what? So you're connected to you connected to its access point? Okay, great. So it should be 192.168.4.1. Yeah, and then you need a colon 8000 at the end of that. All right, so I can see I'm on your wireless access point. So let me see if I can get. Okay, so I get the wireless access point, and
So you're
then
connected to it,
yep,
and you're just connected to 10 with LoisLab. So it's just, my computer just doesn't want to connect.
it seems to be a little cranky about it. Yeah. So when you're here, there's another way for you to get in, which is this thing also simultaneously joins up to our wireless network, right? And so so you can be connected to its access point and talk with it. But then if you need to download files, it can
Do it through
through the wireless network there. So if you want to connect that way, I can.
Now I'm connected.
Oh, okay.
So I tried like 5 times.
I believe you. Maybe me connecting just sort of like jiggled the handle or something like that.
Who knows?
Alright, so it's up, and I've got like a console.
Great.
Is there like a command I click to down?
Yes. So.
There was something last time.
Yep.
I was here.
The easiest way might be to go grab the thing from the Discord. So can you hop on Discord app? Yeah. You're probably going to go in as. I was thinking about it.
Should I just sign in with them?
Yeah. That's probably the easiest thing. And so I linked to the Getting Started guide, which you can ignore most of because you're already connected. But there is a command.
It's in yours.
Oh, that's all right. Just don't send like embarrassing messages to all my friends. Yeah, it's the bottom one, next one down. There you go. And scroll. Let's see. Nope, a little further up. Up. Let's see. Now we're getting in the realm here. It's somewhere around here. Wiring video. There we go. That's the one. Yep. And so if you go down near the end, there should be a command to clone the software repo. There it is right there. So that's 2 different commands there. I think you only really need the second one. So you can just, highlight that. And then if you go back over to Cloud9, yeah, you're already in the right directory there. So it's pulling that down from GitHub. And so what it did is it created this directory here that's called qbot rover. So if you go into that directory, so that's, I don't know if you've worked in Unix before, but you can, you're doing fine. Open up rover.py. So just double click it, And so this is the example code. And if you scroll down through, I don't know if you've done any Python before, but it's fairly readable. Like you can kind of read through all the stuff that's in there. But the loop at the bottom basically just goes forward and turns a corner, goes forward and turns a corner, and does that 4 times.
Okay.
So if you try to run that, you can just hit run. Yeah. Yeah, that's looking pretty good. Yep. So it definitely went forward and then turned a corner. Yep. That's looking good. So one thing I would recommend is, so this basically goes and it makes like all right turns or whatever. So you might want to just change the loop, right? If you look a little further up, you can see where we define the move function, which is like, it's a little bit further. Nope, it's just, it starts, yeah, there we go. So basically move, right? It takes an action, 0, 1, or 2, I think.
Oh, so 90. So if I put that like 270, it'll turn right.
Oh, you could do that, but we've already got action 0 is go forward. See the comment here. Action 1 is turn left, and action 2 is turn right. And down in the loop, which is at the bottom, we go forward, move 0, and then we turn left. So you could change these around, like maybe make it turn left instead of right, or right instead of left, or whatever. But just make sure that the motors move in both directions.
Yeah.
The other thing is that there's, I think move 0 goes forward, move 1 goes left, and move 2 goes right. There's no reverse.
Okay.
It would be pretty easy to modify the code to add another option that would go in reverse,
All right.
which might be a good exercise. But that looks great. That is a moving robot. How you doing?
I don't really have a computer here to connect to this with.
To this with?
Yeah.
Oh, you can use mine if you want. I don't really need it at the moment. What's that? You can use that one, except that one doesn't have a wireless adapter. So let me think. Actually, that should still work because instead of doing the thing where you connect to its wireless, you connect to its wireless access point, this is plugged into the same network that's on. So I can help you if you power that up, grab one of the USB cables and power it up. We should be able to connect to it directly. So the USB cables are actually in the upper right-hand drawer.
So plug it into the computer.
Yeah, just use one of the available USB ports and give it like 30 seconds to boot up. And then which Pi number are you?
I think 12 maybe?
It's on the memory card if you can see it.
I don't think I can see it.
Can I see? Take a look. I bet you I can sneak a peek without taking it out so far that it's hard to get back in. It is 12. Good job. So once it's all booted up, if you open up a browser, you should be able to connect to, I'll write it down for you. So it's going to, when this is all done booting up, it's going to join itself to the wireless, and you'll be able to get to it here. It's LoisLab pi-12.local:8000. And if that doesn't work, then we'll figure something else out. But it might take like 30 seconds or so for it to come all the way up. You don't have a green light. Why do you not have a green light?
It was green.
Maybe unplug it and plug it back in. I'm going to plug it into the power connector instead of the USB connector, which should be fine either way, but. Why are you not lighting up? It's voice activated. That's why I'm speaking to it. Hey, Drew, did you say you had trouble getting it to boot up with one of the black cables? Was there some particular reason for that? It just didn't like it? Okay, let's try a different cable. That was very strange. There we go. I don't know why that made a difference, but I pulled the memory card out and put it back in. I mean, it won't boot without a memory card in it, but I don't really understand why that made a difference. Oh, technology. I okay. So, oh, something just happened. That's interesting. Okay. Okay, let me just take a look at your wiring here. So, ground. That looks okay. So you got 5 volts splitting and going to each motor controller, and then you got the ground wire, which is 1, 3, 5, 7, 9. Negative on both. And then you've got in 1, 2, 3, and 4. In 1, 2, 3, and 1. I don't remember which pins they're supposed to be in. I'm just making sure that there's nothing obviously
Jumping out at you.
disconnected or
Yeah.
anything like that. Can you run the code again?
And it could be solder, it could be my,
Okay, this is, so this tried to move,
yeah.
but it wasn't pulsing these. So the first thing I would do is double check the pins and make sure,
Make sure I'm on all the right.
yep. Basically, and you don't have to watch the whole video, but I think there was a screenshot at one point that showed which wires go to which pins. The other thing you could do is you could look at the code and see it actually in the code in Cloud9.
Right, it talks about the different pins.
Oh yeah, 3, 5, 7, 11, 13, 15. So, wait. Oh, that's the wrong file. So motor.py is something else. You want rover.py.
That could be my problem.
Oh,
there.
is that the what you were running?
Yeah.
Okay, yeah.
That's the first thing that came up.
Yep. So go ahead and try to run that. Thinking about it. Come on, buddy.
It's not easy.
Oh, you're still on motor.py. Okay. Use run up on the top.
Close up here. Okay. Do I want to do that?
Yeah, that's fine.
Yeah, sure. I haven't done any of that.
There you go. Look at that.
And that's it.
Yep.
So you got to just run the right file? Is that
Yeah.
one of the keys?
Well, it certainly helps.
Correct.
What I was explaining to Yorgo is if you take a look, if you scroll down a little bit in the code.
Yeah. Suppose I can close that.
Yep. So, so it's in Python, and it
Yeah.
refers to a separate stepper library that's also in this folder if you want to take a look at it. But
Yeah.
ignoring that for the moment, there is a function called move,
Yeah.
and it accepts one of 3 arguments, 0, 1, or 2.
Mm-hmm.
0 goes forward, 1 turns left, 2 turns right. And so at the bottom, there's just a
Quick.
simple for
We
loop.
create the object, for loop, we do 4 times.
Yep.
And you do a move forward and a turn.
Yep. So you could change that to something else, which might be a good way to make sure that your motors move in both directions, right? So
Right.
maybe you make it turn right instead of left or whatever. Or you could modify the code up here to have another option, which would make it go in reverse.
Right.
You know, whatever you want to do there. But you might want to play around with the code just for a couple of minutes, make sure that this is working as expected. And then if in whatever robot design you're doing, you're going to continue using steppers, you can use this code as sort of a base to work from, right? You know, maybe you want to add another one. Maybe you don't want to use round wheels. Maybe you want to, you know, use the steppers but have a different mode of movement. You know, whatever direction you want to go there is totally up to you. But if you want to keep using the steppers, you know, that can be your code base.
Okay.
All right?
Play with this.
All righty. You're welcome. Crazy. Break the. Hope not. What's up?
So, alright. You got a benefit of myself.
That's okay.
This error.
Channels already in use. Okay, so that happens sometimes when you run the code, it. No, that's not your fault. Or I mean, not really. Gotcha. So what happens is when the code runs, there's a line near the top that initializes the I/O pins on the board, and then it does a bunch of stuff like making the motors move or whatever. And then at the end, there's a line that cleans it all up. It shuts down the I/O pins and basically completes your program. But if you're running a program and you interrupt it, or if it crashes, it may not ever get to that line that cleans it up. And so then you end up with a funny state where you try to run the code again and it says, the I/O pins are already in use. I can't, it throws you a warning. It doesn't always keep it from working, but yes, yeah. So try running the code again, and we'll ignore the warning if we get it. Okay, so, okay, yep. So can you go down to your loop? So, okay, so you shorten the loop, right? So it's funny. You can actually take out the, which is fine, but it's a little silly to have a loop that only runs once, but it's not technically incorrect. You could just, instead of having a for loop at all, you could just do row, like you could unindent these lines and just have it do a row remove, another row remove, another row remove, another, you have to unindent the lines, but because Python is really picky about that, but yep. So you just got rid of the loop, and now you're just basically doing like a list of commands, which is totally fine.
Okay.
Yep.
So that'll do that.
Mm-hmm. There we go. So it's dragging a little bit because you got the chord here, but so what did you tell it to do? You said move forward, turn, forward,
Spin.
and spin. Oh, okay, cool. Now. Let's see. Do you remember in the loop when there was a for loop there? Was there any sort of wait command, or did it just say go forward and then turn and then?
Go forward.
Okay. So can you run it again? I just want to see, because it seemed like that ran pretty quickly.
I've been trying to do them all pretty fast.
Yeah, that seemed to do one thing. Rover move. Can you scroll back up?
Could check, right?
Yeah, I mean, well, what you could do is if you go back down the bottom into your loop, so after that first move, so go to the end of the line, right? And then let's add a print command, right?
Oh, okay. To show us.
Yeah, do open, instead of the period, do open parentheses, and then double quotes.
Okay.
Yeah, and then, just something to indicate. Yeah, there you go. Sure. So you could copy that line and paste it in the other ones. And basically, if it doesn't move, then it should do a print. Then it doesn't move, then it should do a print.
Oh, I didn't copy that.
Yeah, but you get the idea. So then that sort of becomes a little indicator of what's going on. Yep, cool. So you should get 5 of them total. All right, so give that a run.
Oh, there's 5, right? So it did go fast. Wow.
Yeah, so it did the first one fine, and then we'll remove 2, 1, 0, 3. Can you go back up? Did you change the code for what the moves do?
I added, what I did is I added rotation, spin, so like different.
Okay, so let's see. I'm not sure why that would make a difference on one of them, but not the other ones. So it looked like the first move took the normal amount of time, and then all the other ones that you did after that happened really, really quickly. Yeah. So let's see. So did you change anything other than the rotation spin? Or did you add that, or
Yeah,
was
I
that
added that.
okay? And then did you use that? Like, did you use rotation spin?
Down here.
Oh, okay. So let's see, action 3.
Yeah, I got an error before that was because I didn't add the colon there.
Yep. Well, good job of figuring that one out. Let's see.
It's on 33
So, so go back down the bottom and where you call, you actually, so the one that you modified is move number 3, right? So even though you modified that one, it doesn't really explain why rover move 2, 1, and 0 are running so much faster.
Wait, so if we just cancel this out, I can do it.
Mm-hmm. Yep. So there's something about the other ones that are not properly registering. Let me pull up the code for that.
Is there a such thing as like a wait command?
Yep.
That we could
Yes, but if it's not necessary for the one that's working, then I mean that will slow down the fact like how fast the hellos come out.
Yeah.
But it's almost like it's skipping over the actual move, if that makes sense. So let me just pull this open. Yeah, it's like a portable like HDMI display. It's just stuck on here with magnets. Okay, so let's just compare my code to your code. So can you go up to where move is defined? Okay, so move 0 should be, it's moving. Yep, that looks like it's the same. And then scroll down a little bit to action number 1. So we've got self.right wheel, set target rotation degrees. That's the same. So we've got one wheel going one way and one wheel going the other. So let's see. And then wheels move. Did you add that?
No.
That's interesting.
That was here.
Oh, that goes, yeah, that goes at the end. So move that line. Yep. So move that whole line to,
There's a space there.
no, space won't hurt anything. You want to unindent it so it's at the same indentation as this elif. Yep, there you go. So go ahead and save that.
So what is it?
You can do just file save, or I think you can do Control S as a shortcut. Yep. Yep.
Is there like any? Oh, there's. Oh.
Yep. There you go.
There it is.
That's
Alright.
better. Cool. Yep. So basically, when you had indented this,
Yep.
you had moved it inside one of the, like, the indentation is how Python knows the grouping. So when that was up here and indented, it made this part of, like, action number 1. But this line here, well, it's what actually makes it do the thing, right? So this line comes at the end where you say, you sort of set it up with action 0, 1, or 2, and then wheels move actually makes it do it, and then it goes back to the top of the loop and sets up the next action, and then wheels move actually does it. So yeah, it was just moving that indent made it.
So that was do my spin now. Got it. Alright. Forward. Left turn. Right turn.
Cool.
Forward again. And spin. Cool. Let's go. Alright. It wasn't a full spin.
So let's see,
I don't know
you
what the actual-
spin.
Is it like degree based or is it just rotation?
Let's see, rotation degrees. It's a rough approximation because it's like, it's the stepper motor, we're just sending in a number of pulses. So if you want to do a full spin all the way around, you might want to do, let's see, rotation degrees.
Also, is there any way to like quickly just comment on this?
Comment what? Yep. You can do 3 apostrophes, so right here, to open the comment block. You can't do it if you've already got the pound sign comment ahead of it, though.
Oh.
So, yep, and then go down to the end of what you want to comment out and do another 3 apostrophes. Yep, there you go. Cool. So what you could do is, like, in this case, like a left and right turn, it's using rotation degrees as like a number of rotations, but you don't have to use the variable. In your action that does the spin, instead of rotation degrees, try putting something in like 360 in here, and try it again and see what it does.
So it's just kind of like a shortcut.
Yeah. So try that and see how that goes.
Alright. So there was no need for me to do rotations.
There's no need, but there was nothing wrong with it either. Yeah. How you guys doing? How's things in servo land? Sorry, I didn't mean to interrupt you.
Screws are just like they don't actually matter, but the screws aren't following the move.
Did you find a model somewhere?
I did find a model.
That's pretty cool. Somebody even did the label.
Yeah.
I actually have some Tower
Yeah,
Pro
it's not
servos.
the same label, but it's the same thing.
Yeah, that's really funny. Somebody did a very detailed model. So what were you saying about the screws?
They just aren't following it, so I'm just kind of giving up on having those there. Like, I turned it 90 degrees this way, and two of the screws turned 90 degrees this way, and then moved the opposite direction.
That's a little frustrating. I wonder if that was something like one of the models was right side up and the other one was right side down, right, or downside up, or whatever the phrase would be. So when it tried to apply the same move to both objects, one went clockwise and one went counterclockwise. Like, I'm not sure if that's a thing, but that I can see how Fusion would potentially do that. So, not to like upset your workflow, but can you show me what the picture looks like right now? Like, can you zoom out? I'm just curious to.
I'm like trying to like assemble what it's
Oh, I see. Cool.
like. I have the big light here.
Mm-hmm.
This is this is what this is gonna plug into, and
Yep.
it's gonna turn on this. This will be attached to this, and this will like lift
Super cool.
for my first degree of motion.
Nice.
Yes, so I think it may be good to put like this thing.
Mm-hmm.
So make sure that works. Like this thing.
Yeah, it wouldn't be a long print either. So does this fit into here? Oh, that's a different.
No, this is what's attaching these four
To.
each other.
Okay. And so this the geared section of the servo, does that slot into the intersection there? Okay. Cool.
It really doesn't like me changing that because it's like had like a million points.
Yeah. Yeah, that's a little heavy, but looks cool though.
That's why the end of the screw is so messed up because I just clicked this and just pulled it out.
Oh,
Deleted
yeah,
the
yeah, yeah.
entire End of the screw.
Yeah, yeah. Like arbitrarily extruding surfaces does not always have like predictable results.
Yeah.
So that's cool.
That's why I'm kind of just leaving that there's kind of just like floating parts in certain places I'll have to fix at some point.
Yeah. How you doing?
Pretty good.
What you thinking about?
I don't really have anything right now, but I have an idea,
Yeah.
and I'm just trying to figure out where best to start.
Sure.
Yeah. Okay.
I'm just gonna give you a minute. Work through that.
It's I want to do like have the rotation from the motor go change like 90 degrees, so it goes from like straight to like to the side like that. You know what I mean?
Yeah.
And then I also want it to be able to. I just want it like a normal car will like turn its front wheels like this, and they're like universal joints there.
Sure.
Or yeah.
Mhm.
And then so, but what I'm first doing is like the wheels that goes down like rotation from one axis to another.
So what are you using to drive the wheels? Like what is actually
Just
going to
one
make
of
them
these
go?
motors, I'm assuming. I don't need to go fast.
Okay. And so let's say that you have one of those motors. You're saying you want to change the direction of rotation? Like you want to have the stepper drive something that changes the direction of rotation and then moves the wheel? Or do you want the wheel attached directly to the motor?
No.
Okay.
No. So what I was thinking was the motor, a beam comes out here, and at the end of it, there's a gear. Either, I'm not sure which one, but either this would be a large, there's like, well, in my mind, what I have is there's either one large gear and two smaller ones, or a small one and a, oh wait, no, it has to be two large ones and a smaller. No, it could be two smaller ones and a large one. But it'll do like, you know, there's a beam that comes out, and on the end of it, there's a bunch of little teeth on it. And then there's a plate, and it's got teeth on the edges.
Yeah, yeah.
And then it turns like that.
A silly question though.
Fusion.
Okay.
So,
So, well, there are different ways to generate gears in Fusion.
yeah.
But depending on sort of the accuracy or the precision of the movement that you're going for, you don't have to overthink it.
Okay.
Like I could show you an example of something, I swear to God, I made it out of wood, where it's a disc and a series of pins.
Oh, yeah.
and another disk with another series of pins, and that works just fine,
Yeah.
right? The way that I arrange it, there happens to be a lot of backlash, as they say, which is if you reverse direction, a certain amount of stuff that it has to get picked up. And so the advantage of like traditional toothed gears, a lot of times is the shape is to avoid backlash,
Yeah.
right? But if, you know,
It's a lot. It's on a really small scale.
yeah, and as a first step to get you going, like you don't necessarily want to fall down a week-long rabbit. The perfect way to design a gear, right?
Yeah,
You know, just like basic functionality is a good first step, right? But so let me ask you a question. If you have a stepper motor, right? Like in this case, it's mounted vertically so that it can turn a wheel like this, right?
Okay.
Yeah.
Yep.
If you want to change the direction of rotation, why would you not just turn the motor?
Well, I think part of the cool part of it is having it
Okay.
right down the center and then change direction.
Okay, that is a perfectly valid answer.
Yeah.
I just wanted to throw it out there
Yeah,
on the off chance you hadn't thought of that.
I mean, I assembled the robot like this, so that,
Cool.
Yeah.
All right. I'm totally in support of that.
I know that this course is supposed to be like make a robot, and then the next part is like do the programming stuff. But I think I'm a little more interested in like the modeling thing because I'm not so great at the programming stuff.
Well, one of the ways, what?
I feel like he's agreeing with me.
Yeah. Well, one of the ways that you get better at it is,
Yes,
but
I know.
yeah,
I
but no,
realize.
like, I mean, if I had one goal, it's to set you guys up with a set of skills that you can use to pursue the project that you want to pursue, whatever that is,
Yeah.
right? You know, we talk about things a lot in terms, like in the context of artificial intelligence, for example. But if that's not your thing, that's fine, you know. Like, so yeah, if you want to focus on modeling of mechanics, you know, in a way that's interesting to you, then yeah, 100% do that. That's like absolutely cool. So awesome. Okay.
Yeah.
So, so getting back to the gear idea,
Yeah.
do you need help getting started?
I'm just gonna look up a ton of YouTube videos
Yeah.
until I figure out how to do
So there's one more thing that I want to throw out at you as a consideration.
it. Okay.
So in Fusion,
Oh.
if it's still here, sometimes they move things. Let's see.
I thought maybe, just maybe, I could use like the thread function, the thread thing to make a gear, but that did not work.
So it looks like they.
Preset screws.
It looks like they moved it, so I will Google it. But basically, Fusion can be extended with scripts,
Okay.
like either Python scripts or whatever. Yes, and one of the examples that they included was a gear generator. And so basically, what you could do is, yeah, you could give it the diameter. It asks you for some kind of specific parameters that you need to kind of look up, but basically, it allows you to specify the number of teeth, the size of the teeth, the diameter of the teeth.
What if I wanted to like twist the teeth?
Oh, so also a thing.
Yeah.
Yep.
Yeah.
You can, I think you can extrude with a rotation, actually.
Oh,
But so,
Aggressive version of the plugin.
yeah. But so the other thing that you can do is, you know how in Fusion you can start a sketch, and then you draw a two-dimensional profile, and then you extrude it?
Yeah.
One of the things you can do in sketch mode is import a DXF or other 2D, not DXF, well, you can import a DXF, but an SVG, which is a vector graphic file. And there are all kinds of gear profile generators online. So, for example,
Is that just the direction the teeth go, or that's not how big the teeth are? I'm confused.
yeah. Let me show you.
Numbers and letters, I don't know what's going on.
There are numbers and letters. So, okay, I just Googled SVG gear generator.
Okay.
So I haven't looked at this one before, but let's just take a look at it.
Well, I'm just a mock.
Okay. So, right? So, you plug in parameters, blah, blah, blah,
Wow.
and then you say download SVG. SVG is a vector graphic.
Yeah.
You can import it into a sketch and then extrude it, right? So you can plug in the parameters for the gears you want to see, export them, import them into Fusion, extrude them, and then you've got your gears.
What is a vector graphic?
So, okay, this is going to get a little bit nerdy. Okay, I'll try to give you the short version. All right, so a lot of graphic files, like an image, like a photograph or something like that, are what they call bitmap graphics. If you zoom in super close,
Yeah.
it's made up of pixels, right? And if you zoom in, it looks
Why
really
does it
grainy.
put audio to
Okay,
the-
a vector graphic is different in the sense that
Oh,
if you
is it a
zoomed in,
point?
it's actually line information. And so what that means is, like if this were a bitmap graphic of a gear, when you zoomed in, it would look all like jaggy and stuff
Yep.
because it's pixels.
Yep.
But a vector graphic basically has information that describes this line between this point and this point, another line between that point and that point, and so on all the way
It's
around.
like math defined.
Yes, and what that means is when you zoom in super close, it just redraws the line, so there is no loss of information or jagginess.
Okay.
So vector graphics, when you import them into something like Fusion, it's line information as if you had drawn all of those lines by hand, and you can use that information to then extrude into a three-dimensional shape. So vectors are where it's at in terms of importing sketch
I
information.
see.
I'm sorry if I made your head explode a little bit there.
No, I'm trying to understand it.
That's okay. It's just one of those things where it's a little hard to describe in the abstract, but once you go through it, it's no big deal. Like, I don't know what this is going to do, but let's just, oh yeah, of course this one they want.
Oh wow.
That's okay. Let's see. Oh, you know what? Let's see, here we go. Does this have an SVG download?
I don't know how to do this, so we're gonna see how this goes.
You make a bolt.
Yes, I did.
Here we go. That's what I'm looking for. Oh yeah, of course it is.
Do I just leave all the settings default for printing?
What's that?
Slicing. Do I just leave all the settings default?
I usually do,
Slice
unless you're looking for.
something specific. So like,
How is this any different from the
That
thing I
looks
was just saying?
suspiciously like the last one. It's just not inside. The teeth are on the outside of that big.
Okay, are we in just like an internet loop here?
what are you in the middle of? Where have you gone?
Yeah, we've fallen into like the bottomless pit of gear generation on the internet.
But can it run Doom?
Okay, so that's cool. Oh, all right.
Oh, I gotta get Doom for the calculator.
Oh, wow.
That's actually fine though, because DXF is just another. It's an Autodesk
There's
format.
so many G-code files.
Oh, okay, yeah. So you can plug in the parameters here, and then all right. So, did it actually download the file now? Downloads. Yep. Nope. There we go.
There we go.
So if we go over into Fusion now, and let's say I do a new sketch, I should be able to insert DXF. So SVG is just another
Yeah.
option.
Okay.
So DXF, and then select the DXF file.
And this is put a gear in. I thought I'd have to do like something else.
Well, you could. I mean, like,
Is it just a 2D? Is it just a sketch?
Yeah.
That it's gonna put in.
yep. And so, so basically, it looks like we can change
Oh
things
no, it
like.
gave you an error.
Okay, well, we'll
failed.
fix that in a minute.
Yeah.
Let's see, tooth count. So, you know, if we change this to like 15.
What if I want?
Oh, there we go. Update. What were we gonna say?
Oh, wheel 2
Yeah,
teeth
there we
count.
go. Yeah. So just
Oh,
like.
that's so nice.
Okay. So why did this error out? Okay. Well, that's fine. Like, just do it.
Does not contain unit information. Is that what it just said?
Yeah, like millimeters or
Yeah, yeah,
inches
I've
or.
got it.
So that's fine. Design files, designs, units will be used. You can change this in the units dropdown. Totally fine.
Maybe it did import. Maybe you're looking at it really close right now.
No, I don't think so. Let me.
Like if you zoom out.
Oops. Yeah. So. Yep. It's not. Yeah. Like it's also not showing my grid right now, which is a little bit weird.
Oh, I thought you had zoomed in so far you couldn't see the grid anymore. I was like,
Blurring out. What? Sorry.
Mine has a mass amount that I can't zoom in.
Really, like limits you?
Yeah, because then it'll like crash and lag or something if I zoom in further.
And then new sketch. And then insert. Nope. Insert DXF. If this doesn't work, I'll generate another one and try it again because I don't want to be like stuck on a weird buggy file or whatever.
maybe.
What were you gonna say?
No, nothing.
Okay.
Oh no.
I like how you click on more information
And it just does
and
the
it says
same
exactly
thing.
the same information. That's super. That's
It's just like a. The window isn't even anything. It's a report window. There's a bit more information in there.
Oh, what do you mean the font got small? That'd be the worst way to show more information. The font gets smaller and more shows up.
so this is like the.
That's just like
Oh man,
Anti-
this one thing, you just stuck
maybe
it
really
everywhere.
stupid, but how do I turn the printer on?
Oh, power switch on the right hand side.
Maybe.
If you just ruining my printer habits. If like the difference between like rotation and
I
hand
think this is the one we were just on.
being the exact opposite.
Can't you change it?
I'm too
Okay.
lazy.
So worst demo ever.
Yeah.
On the other hand, I didn't write it. So anyway, it is absolutely possible to do this.
There's a way to do it.
Yes.
This was not the way.
Right. So
Time to print. This is probably not good to print today.
what's that?
Stuff is that.
It might not be done by the time you have to leave, but that is not a reason not to do it. You should kick off the print so it's done next time we get here.
Okay, not my little thing.
Oh, we should swap out filament. You're on NinjaFlex right now.
Oh. Yeah, I
Which-
probably don't.
Which would be a really like.
It'll work no matter what I do. Because it'll just bend.
So if we go unload filament. So PLA is probably fine. So we'll let it warm up, and then we'll go back to the previous menu and pull the filament out and just swap over to this.
Now it's now sitting in my dining room. I only have one.
Is it what model do you?
It's CR10S.
Creality?
Yeah.
Cool.
There's a big old Black Friday sale.
Nice.
Which put it down like $250.
That's great.
It's a huge printer.
Yeah,
300 by 300 by 400.
that's really big.
It is big.
Like we built one at the Makerspace that was that big, but like yeah, it's like print a basketball size. It's
Kinda
like
sad
absurd.
when I went to UVA and I didn't get to see the really big one they have.
Oh, the one they used to
So-
print a boat.
Yeah, it's like the
Yeah.
boat is like tiny compared to the printer though. The printer's like 100 feet long by 25 feet by like 10.
Yeah, that's pretty awesome. Did you guys all see that? There's like up at UMaine, they 3D printed a boat. They built a printer that's like a warehouse. Yeah, and it basically printed it started at one end and printed the boat along like this. It was like this huge gantry.
And anything with plastic, the prints are,
Like 72 hours or something like that.
I think they use like car motors on it.
Yeah, well, and they also used a nozzle that's really, really large because when you're printing something that big, like you don't want to print out this much plastic at once. You want to like be hosing out plastic. It's
0.4 millimeter boat.
press the knob to unload the filament.
Click. Ta-da.
That's pretty pretty straightforward. And then we could just do auto load. Okay. So it's actually got a filament sensor, or filament sensor.
That was one of the things that was good for mine, is if it ever ran out, like, prone to be able to continue.
Yeah, that's one of the things that I love about these, is they do a good job with that.
Power outage thing too.
Yep. Come on, buddy.
No, like when we ordered it, we were like, it's either gonna arrive in like 5 days or like 3 weeks.
Was it like shipped from China?
I don't know where it came from.
Okay.
They may have shipping centers in America. It did arrive in like 4 days or something. But we really didn't know what kind of shipping experience we had.
Yeah, right. So do you have the software on your computer? The Prusa
I
software?
already loaded the slicer.
Oh, it's already on here?
Yeah.
Okay, cool. You should be all set then. Hello.
So, these are DC.
Yes.
Okay.
Mhm.
So they have a gearbox on them. Is there any way I could test like how fast it could go?
Yes. But to drive a DC motor from a Raspberry Pi, you need an additional part in the middle, like I have on mine. And so you can definitely get started on this. But so it's like the way that I've set this up is that chip in there is the H-bridge motor controller. So basically, the Pi talks to it, and it controls the motors.
Yeah.
So
I just want to see like how fast it could go.
sure. So I'm trying to think of the easiest way for you to figure that out, because basically these motors can run on anything up to 12 volts. So if you run it on the low end of that spectrum, like around 5 volts, it's going to go slower, and 12 volts is going to be faster.
Is the gearbox like upscale or down?
Down, because like this motor by itself would run at like 5,000 RPM, like like super fast, and it would have no torque.
So yeah.
Right? Does that make sense?
Yeah.
So one way to try this out. Yeah. So let's see.
Got a nice little
I actually have a bunch of those that don't have
flipped off.
thing. Let me see. Because I don't know if this is charged or not.
What happened to this one?
Which one?
Dead.
Yep.
Oh.
Okay, yeah, this battery's just fine. So, these batteries can put out a lot of current. So if you hook up wires like this just for a quick test, you got to make really sure you don't cross them, because the battery can catch on fire. So don't do that.
Yeah.
But basically, you can stick one through like that, another through like that. So this one runs about that fast, okay?
Alright.
But some of them have slightly different gearboxes. So
Yeah.
you can try that one and see if it behaves differently. But also remember, also, you can just do it that way. So remember that like this thing looked like it was rotating at probably something like 120 RPM or something. So per second. Keep in mind that if you have something like a small wheel on here, it's going to move slowly.
Yeah.
But if you put a big wheel on there, that's basically the same as gearing it up, because it's rotating at a constant speed.
Yeah.
So if you put linear travel,
Yeah.
yeah, makes sense?
All right.
So you can, even if it's not ideal, okay, that's
Well,
that's
way
faster.
faster.
Yeah. So more of these in that box. You might want to try to see if you can find two that run at about the same speed. Okay?
Got it.
Take this with you. I am just
Yeah.
careful not to start a fire.
Okay, I
Thanks.
just got
What's
a
up?
very strange situation with an arc in Fusion.
Okay, let's take a look.
Um,
He's got an arc situation. Everybody be careful.
If the bed heats up, mine might actually finish. It says like 15 minutes.
Oh yeah.
so this is
Okay. Yeah, that you got a bit of an arc situation going on there.
like it's just that one position. It's only
Oh, I
Going
think.
along this line,
Right.
but not on that point.
Okay, that's a little confusing. So what are you trying to do?
Because I had like gotten it from, I had drawn it from over there. So
Mhm.
something. Oh, that's what it was.
Oh, it's actually it's coming out. It it's not
Oh.
drawing it on that plane. That's really strange.
That feels like the size of the drawing in game.
actually did.
That's I didn't. How is it doing that in sketch mode?
I have
Normally.
3D sketch on,
Oh, okay.
but that's the only reason I could do that.
Gotcha. Yeah, but so when you turn on 3D, it's mathematically trying to make it happen, and in this case, it meant that it was drawing the arc out this way instead of on the flat plane. So
Okay.
interesting. I've never seen
There's
that
the
before.
center point, and for some, what the heck? Okay. Sketch point. What? Why is that a sketch point?
That is the center point for this arc.
Yeah.
So it's basically the construction.
Darn it. It's not even close to this. Oh my god. Wish me luck.
You'll get it.
Potato. I'll get beat up.
Oh, okay, cool. Did you find a couple you think that
Yeah,
will work?
these two.
Great.
Two. Yeah.
Okay, so
I've got an idea.
great.
Yeah.
Do you want to talk about it, or you just?
Yeah. So I want to do like a heat-seeking robot. Like it just goes.
That's a great idea.
Like object.
Mhm.
Kinda.
I like that.
Yeah.
So next week, I was going to talk a little bit more about how I wired up the H-bridge, because that sort of makes sense in the context of driving these little motors. But if you want to get started this week, basically what I did is I have some more of the circuit board material. And I think I need to look around for a minute, but I have some more of these chip sockets. So basically, you can put a socket on the board and solder it in place, just like we did with the headers on the Raspberry Pi.
Yeah.
And then you put header pins next to it that you solder to the pins in the socket. And then when you plug the chip in, it allows you to plug the plug wires directly in and wire everything up. So it makes it very straightforward.
Got it.
Okay. So I actually have a document that I can go through in the Discord that kind of walks you through the process of putting the whole thing together. So do you want me to see if I can find the chip socket? You can heat up one of the soldering irons and start working on that if you want. Cool. All right, let me go and grab that for you. That's weird. Those settings don't. Why is your bed heating to 105? Hang on, that's really hot for PLA. Let me just stop this for.
The other thing.
That would have been determined by your settings. Can we take a look
Yeah.
at that real quick? Pull that up and let me just grab this thing for Jurgen. I mean, Jurgen. Sorry. Okay. You're gonna need. Yep.
Same motor in our robot.
You're gonna need at least one of those. Your filament setting set to. Aha! And
So wait, this is the H-bridge chip.
yep. Gonna need. I think the sockets are on my desk, so I'm gonna grab those for you. Yep. Pull that thing out. Yep, just like that. Yep. You take that, and need some of those, and then let me go find you a socket, and then I'll get you rolling.
I think it auto set it to like AVL or something.
Oh, okay. Yeah, no worries.
Did you really? Yes.
Okay.
I found a
Here's your socket. The pins are really delicate, so you're going to want to be a little careful with those. And then let me send you a link to.
Yeah, I don't know how exactly these like breadboards work.
That's okay. They're actually very straightforward. What'd you say, Drew? Oh, no. Was it you? I'm sorry. I heard your voice and thought it was Drew. Oh, okay.
now it's just going. Now it's just instantly starting because the bed's already really warm.
So there's a power strip under every workbench. So if you look underneath, see the bit.
It's like it's like directly on you, like right under.
Yep. If you take a look under here. Yeah. So
Here.
Yep.
I thought it was like. Alright.
Why does it say it's heated? Oh, that's filament. That's fine. That's supposed to be hotter.
what's the set point?
215.
Oh, that's fine. Yeah, that'll work okay.
No, it's heating the film and cooling the bed. 'Cause the bed was like 80. No, but I can just stay a couple of
I guess Cody's watching the stream again because he just posted in a link to the article about 3D printing the boat.
Off to the races with it. That won't be too bad. I'm at like 840.
It's just colored it to look like lasagna.
Tape? Probably some in a drawer.
See, does it matter where I place this?
Nope, anywhere you want. Basically, these are all just solder points that you can use, but none of them are connected right now. So come with me for a second.
Yes.
Right, so I've just posted this in the Discord. Okay. Now, this is actually an assembly guide for the little mini bot, but if you take a look, this whole section here is on building the motor controller, right? So see, we got the chip, the pins, and so it goes step by step through putting the socket on, putting the pins in, and then like soldering the joints. And then the way that you connect the pins to the sockets is you actually, let me zoom in here a little bit. Yep. So see how you bridge them there?
Yeah.
Now, this might take a little bit of practice. So if you try to do this and you have trouble, what you can do instead is we've got some spools of wire in the drawers. And what you can do is you can just run a little tiny piece of wire between the pin on the socket and the pin, the bottom of the pin, like that you plug into. And when you put a piece of wire between them, then you can just run the solder and kind of glob it all together. But if you read through this, it describes how to bridge all these connections. And after you try it once or twice, you'll probably get it just fine. Okay? So, okay, there you go. Just be careful moving the iron because it's been heating up. So just be a little careful with it.
One game on my wish list.
I'm just hoping this works at this point.
I know.
What's that?
I'm just hoping this sort of works.
It's definitely interesting geometry.
The subject is notable.
Patience, Jaden. This is neat. Nice. Oh, cool.
No,
There's definitely incline.
no.
Basically, I'm turning one wheel twice the other
Yeah.
right now. But I was sort of forward turn.
Mhm.
And I was like, well, what if I...
You know what might make this a little easier for you? Whoops. This isn't fully charged, but you'd have to shut it down.
Now,
But you can.
what's the trick to shutting these down? This versus just unplugging it.
Well, you can do that, but it's not the healthiest maneuver. So, are you still in Cloud 9?
I'm in Cloud 9.
So, if you go, let's see, you kind of want your bottom pane back.
I don't know how I got that. I'm gonna guess view.
Yikes.
And console.
Yep.
Wait.
Nice.
Look at me figuring things out.
Yep. So, where it says bash is a bash shell. So, in here, you can do sudo, sudo.
S-U-D-O.
No P, just sudo.
Oh, sorry.
That's all right. Space.
PLA
Shut down.
with the wobbly motor mount.
Space. Yep. Now. It's catching up to you. It's being a little laggy.
Yes. And now is what you wanted me to type.
Yes. And then you hit enter. And it'll think about it for a moment, and then the green light will blink a few times.
And it shuts down.
And then when it does that, then it's down. And so you can run off of this instead, and then you're not. Yep. And so I don't know exactly how much runtime you'll get. But,
Use on the,
sorry, 1 second. What?
what
I
did
do.
you slice it?
Where did the rubber? Oh, they're there. So, Drew, sorry, what were you asking?
Hit the bottom.
Oh, the print bed's not on there.
That would be that.
Hey, when you get a second, can you throw away the support material pile?
Oh yeah.
It's okay, just before you leave. It's fine. You're going to want this. Otherwise, it's going to be really hard to get the print off. There's a can right behind the door here. It's cleverly hidden.
So also, his has 200 degree moment, 0 degree bed.
Okay, that's less than ideal.
How do I change? I didn't change my name.
Okay, where are you running
He
the
emailed
program?
it to me, and then I put it on because he's using that, and that doesn't have an SD card reader.
Oh, I actually have an SD card reader, if that's helpful.
Yeah, you should
Okay.
probably change the setting. I can just put the settings up. Other thing. Use back codes. 16. First layer is Jack and
6B.
Other layer. Ooh, thank you.
You're welcome. So, Jaden, what are you thinking about your robot?
My mind is kind of sound.
Yeah, but you got the whole week, right?
robot made of Destiny done all.
How can you incorporate sensors and motors into your Destiny weapon designs? Robots come in all forms.
Oh. I can make a ghost shell.
I don't know what that is.
Ghost shell.
Show me.
There's a lot. Just show up, yeah.
There's
Just show up.
definitely some easy models out there. I would do that in multiple parts though, so you don't have any overhang.
I like that. Like the common language that like most of you in this room speak is Destiny 2.
Yeah, this.
I have played like 2 hours of a Destiny.
Oh, that's because you're.
That's
stupid.
more hours than I have. Oh, that's pretty cool.
Hey, look, somebody did a 3D
Oh,
model
I know what
already.
that is.
Yeah.
That's
no-
because there's no
way-
part of like.
There's no you don't know what that is.
Oh wait, holy cow! How did we get to? Wow. Okay,
This is the kind of thing
it's like 8:30, guys.
that I want to do, but I can't because it has hovering parts.
So you know what this reminds me of though? So I forget who it was. I'll dig up the article and I'll throw it in the Discord. But somebody designed a cube with a gyroscopic mechanism inside that spins and then can flip itself up and balance on its corners. So basically it's a cube, a metal.
Somebody put a gyroscope in a.
Yeah. Enough internal mechanism that it can actually fling itself up onto its side or up onto its corner and then balance there. I'll send a link to the Discord.
No SD card is inserted.
Is that because there's no? Did you? Let me see.
It's really hard to put in.
No, it was.
It goes in.
It was just not.
It goes in the
Yeah.
other way. It's going well.
Okay, guys, time got away from us a little bit. It is 8:30. So for next week, What I want to talk about, we're going to move in the direction that Yorgo is already going right now, which is controlling motors other than the steppers that you guys started with, right? So basically, I don't know what your relative comfort level is, but you can, based on the example code and the wiring that we've already done for the first robots that we assembled, you could probably figure out how to use the steppers in another project. But if you want to use DC motors, you're going to need something like an H-bridge, which is what he's building. We can also talk about servos, right? Have you tried making a servo move yet? Okay, it's actually quite straightforward. So if that's so if you want to figure that out on your own, feel free to go ahead, and we could talk about that next week. I could put together an example, or
I made one move because I have an Arduino sitting on my desk at home with
yeah.
an exact copy of that servo plug.
Okay, cool.
I'm like, wait a minute.
Yeah. So what we can do is we can just find a quick code example that just sends the right sequence of pulses to make the servo move.
It'll just like turn back and forth.
Yeah, we could do that as an example. The other thing that's cool is if you can make a servo move, you can control an ESC for a brushless motor as well because they speak the same language. Right, so that's another option. And then if we have enough time, I usually like to talk a little bit about scavenging because my favorite way to get parts is scavenging. So maybe I'll bring in a couple of things for us to take apart and so we can harvest parts from other things because that's how I get some of my best stuff.
That used to be my main source of
Yeah.
organ harvesting.
So, okay, so that'll be next week, right? So H-bridges, motor control, yeah, anywhere on my desk. H-bridges, motor control, servos, and maybe scavenging of parts. Is that cool?
I have so many like
Right.
RC car motor controllers.
Yeah, those are great for robotics. We're also going to have to talk about safe power control a little bit because once you get into ESCs, it gets a little dangerous. Like you can hurt yourself. So, all right. So if everybody could put their stuff back in their containers and back in the rooms, if you've left any piles, please clean them up. Yeah, that's okay. You take a minute. Assuming that your family isn't freaking out. But when you get to a good stopping point, just all the stuff you got, you can just put it right in your bin and we'll pick it up again next week. Sorry, I was taking this.
Yeah, what kind of shape of like a robot should I take if I want to do like, because I know I could do it more compact than this because I could have the motors going outwards
Yeah.
and then just vertical.
I think you should visualize it any way you can. Sketch it on paper, draw it in Fusion or Blender, whatever you're comfortable with, right? Do you think you might have time to think about it a little bit and work on it over the next week? Because what would be great is if you could put together have a great night. If you could put together a sketch and post it on the Discord, and we could talk about it during the week in the middle.
Yeah.
Which is a great way to kind of keep momentum going. You know?
All right, so what should I do with this?
Just hang on to it. Do you have your bin of parts somewhere?
It's over here.
Yeah, why don't you hang on to the board that you're soldering, the chip, the motors, and the pins. Just keep it all in there. And then you can pick right up where you left off.
Yeah.
It's okay.
All right.
I'm gonna wait till like 4 minutes till my friend is done.
Yeah, it's fine.
It's like 80% done already because it's so small.
Cody, if you're still listening, have a great day.
Should I just kill it?
Yeah, technically you should shut it down. Actually, let me show you how to do that.
Just shut down now.
It's sudo shut down now. So if you're in the console window here, like where you can give it commands, so sudo, which is basically run as root. Yep, exactly. Shut down now.